This video will demonstrate how to create perforations over a surface of a part using implicit modeling in Inspire. To begin, you will need a model which contains a surface you want to perforate. In this example, we will use this solid cranial plate. The first step is to use the Geometry Extract tool to extract the surface that we will use to generate the seed points for the holes. We will also do a subsequent operation to extract the boundary curve of the surface. Select the surface and switch to the Implicit Modeling ribbon and select the Stochastic Lattice tool. Switch the point generation type to From Part Mesh and select the Sample UV mode. In the Edge tab, switch the Edge Generation method from Part Mesh as well. Now we can choose how far off the surface we want the tool bodies to start and end. Negative values will go into the surface and positive values will extrude away from the surface, along the surface normal. Use the U and V spacing parameters to set the density of the points along the surface U and V parameterization. The smaller the spacing, the denser the points will be. Accept the point edge set, and you can see the tool bodies thickened in the next stage. Change the default thickness using the strut thickness parameter. Now we are going to filter out these points that are too close to the outer boundary. We could have converted the curve to implicit beforehand, but in this case, accept the stochastic lattice and roll back the history one step. Open the Convert tool, select the curve, and accept the conversion, and roll the history back to the bottom. Edit the stochastic lattice, and then add a new filter using the plus button. We want an edge filter, and switch the filter type to field value. For the reference field, create a new field. Reset the default driving function, and select the converted curve, and disable the rescale parameter to use the raw field from the curve, and accept the field. Switch the field value condition to greater than, and then use the value parameter to choose how far away points should be from the curve to pass the condition. Accept the filter. Now we are going to switch the outer body tab, enable the Boolean mode, and switch to the subtract Boolean type. Enable the target body selector and pick the original solid part to perforate. This will cut the tool bodies out of the selected target part. We can change the strut thickness and see how it defines the diameter of the holes. When you are happy with the perforations, accept the stochastic lattice. We can also add manually defined holes using the point cloud tool. Enable the background value, activate the field, and select the body you want to add manual holes to. Then, simply place points on the surface where you wish to add holes. Once you have defined all the points you want, accept the point cloud. Open the Stochastic Lattice tool and select the same object we used in the Point Cloud tool. Switch the Point and Edge Generation methods to From Part Mesh and switch the Edge mode to Normal at Point. Just like before, you can define the start and end distances to the surface. Accept the Point Edge set and switch to the Outer Body tab and enable the Boolean. Since the target of the lattice was a solid body, it will automatically use that as the target body and combines the tool bodies with it by default. This will create pin-like structures. To perforate the body, switch to the subtract mode. The hole diameter can be changed using the strut thickness parameter, same as before. Accept the stochastic lattice to finish applying the perforations.